recording started. So let's start. So today we are going to discuss the topics. Those are STP protection. STP protection means you learn already the STP, right? What is STP? What is how it works? Okay, how we are selecting root port, how we are selecting, root bridge, DP port, and so on, right? So in the current whatever STP scenario we have learned till now, so in that case, might be some challenges can be occur. Okay, to solve those challenges, solve those issues, okay, solve those bugs, you can say, we are using some protection, and this protection is being used in real environment. Okay, so every company are using this kind of scenario. They are uh, putting the configuration on the place, on the devices, and those configuration are going to protect our spanning TC, setup. Layer 2 setup. So first is a loop. First we are going to discuss about the root guard. So as a, you can say, let me show you. As the name suggests, root guard. Root guard means guard the root. Means we have scenario like that, right? You already learned these things. We have scenario like that, multiple switches in the network, and then this is become a root, for example, root, and this is non-root switches. This is non-root switches. So what else if some attacker has came, for example, is came the PC connected here, right? And say this attacker is saying like middle of the man attack kind of, you can say. So it's saying I'm the root. I am the root. In that case, all the switches will consider this is the root, because why it, how this attacker can say that I am a root, because some of the multiple malware software in the market, okay, they can install in the PC, and his PC will start working as a switch as well. Okay, so they can configure root bridge and everything they can configure. Okay, so how any switch, any device is layer 2 device is deciding like I'm a root, right? Priority and MAC address, lowest priority and MAC address. If priority get matched, then lowest MAC address will come into picture, right? Remember?
Yes.
Okay. So in that case, if this attacker says like I'm a root, after that, what will happen? Right? This all this is root switch. It will generate hello configuration BPDU. This is non-root switches. They will generate the TCN BPDU, topology chain notification BPDU, and converts the topology according to this system. This root also will convert this topology. Some port will become a root port, and some DP, and this port will become a DP, and this will become a root port. Kind of, right? Scenario will happen. In that case, all the traffic will start flowing this one, and attacker can misuse those data, right? To protect this kind of scenario, we have a term or topics known as a root guard, means guard the root. In that case, if any PC will connect here, let me take another scenario here, new one. Okay. Okay. Root, for example. Root. So in that case, if attacker came into and connected it network, so what will happen? We can use the root guard, and we can say if any device or any attacker coming with lowest root bridge ID, lowest root bridge ID, root bridge ID, what is lowest priority and MAC address, root bridge ID. In that case, just drop the packet, drop the packet. Means if attacker coming with the lowest root is ID, I mean become a root after converging this topology. In that case, if someone is coming with the lowest, like I am the best kind of, okay. In that case, we will not. This current scenario will not entertain this type of, you know, this layer 2 topology will not consider this device as a root device. Root, I mean root, what we are calling as a root switch, right? So how you are going to apply and how it will protect? Let's explain here. Till now, is there any question? Any question? No.
Attackers means you are talking about like hijackers kind of, right?
Kind of. Yeah. Attacker means who is running the malware, like is running virtual switch, for example. Some VM is running and VM is having the virtual switch, and it's making virtual switch priority as a 0, for example. Priority 0. In that case, by default priority, which we have 32768, okay, then this is a lower. Always lower will become a root switch. So if someone is coming with lower priority, then this device should not entertain. I mean, current scenario, current topology, current design should not entertain kind of user or kind of switch, kind of device. Okay. Okay. Now, how you are going to apply this? This is the switch you have. This another switch you have. This is another switch, for example. Because I cannot make myself as attacker, so we will take a switch which having lowest priority, that is priority is 0. This is current scenario is running up. Okay. So root guard we are going to apply on DP ports. All the DP port root guard will be applied. For example, this is bridge, this is bridge, the DP. We will apply root guard here. For example, this port is a DP port. So DP, this is a block, this is RP, this is RP, for example. Okay. In that case, this DP, and this DP, we will apply the root guard command. After that, once it's received the packet, what will happen? So it will receive and it will start forwarding the DP port, right? It receives the superior BPDU, and root port responsibilities forward any kind of traffic. Any kind of traffic it will forward. Okay. DP or RP, doesn't matter. Okay. This DP is dedicated for transferring hello BPDU. So it say like I have received the superior BPDU and I need to forward with you, but I need to become a DP port kind of. It will converge like that topology. But as soon as DP port receive the superior BPDU, and we already apply the protection. That is the protection is the root guard, and then it says like I will not entertain any kind of traffic which you are sending, because we are running a protection known as a root guard. Okay, then it will put that port here, and this port is DP. It will put those port into root inconsistent state. Root inconsistent state. Consistent state. Means as soon as DP port will receive the superior BPDU, okay, it says like I will not entertain, and it's put as a blocking root in inconsistent. What is mean by this root inconsistent state? Means it is might be you will see as a blocking port BLK, or maybe you can see some cases irreducible, or you can say it's forwarding only, but no data traffic will be forwarded. So if port is right side in where you can say is P2 port, P2P port, okay, okay, and you can say is means it's we have port first enable, right? And after the port, I mean this port status, you will see root in inconsistent state, and later on you can see the state, which state this packet, I mean your interface is, okay, in the spanning tree. So might be it's a bit confusing one, but let me prove that. And let me, take a lab. Give me a moment. Let me on the log in the things, and then I will share the screen. Okay. Let me on the what be called DNS as well. Cool. Let me know if you're able to see my screen again. Is there any message or then is coming? So just take little bit theory. For example, if someone asks what is a root, how you need to explain. So in that case, just take little bit. After that, I will start doing the lab. Give me a moment. Okay, you can write something. There, there are types of protection. NSTP below. As below, first it's root guard, right? Root, yeah, root guard. It's going to protect root switch. If any device will come up with lowest priority and start claiming the root, in that case, the root will not consider. Well, it makes sense, right? And second, we are going to apply on the GP port. Why you cannot apply on the RP port? You know, right? I will prove that one as well. Because if you will stop, you will apply on the root port, so it will create a big problem. because as soon as root port will receive the BPDU, it will put that port into inconsistent state. So working infrastructure also will be breakdown, right? That's what we cannot enable on the root port. Okay, we are going to apply on the root port. That's it. And next, is there anything else? Let me see my notes. Okay, there's no nothing much here. Okay. Then third point you can say as soon as DP port will receive as soon as DP port will receive the BPDU, so BPDU will drop that port into root inconsistent state. You can say STP root STP root inconsistent. Okay, done. Give me a moment. One more thing is remaining to explain you guys what happened with the this switch. For example, we have three switches right here, and the taker is connected here somewhere. In that case, one PC is connected here, one is connected here. 1.1.1.1. Here IP address is 1.1.1.2, for example. They are communicating. As soon as this device will come up with lowest root bridge ID, okay, in that case, all the DP port, this is also DP, this is also DP, just I'm considering. This will, put into blocking state. This also put into blocking state. Then virtually this switch isolated from the network, right? This switch isolated from the network until unless is receiving the BPDU, it will be in isolation state until unless it will stop receiving the superior BPDU on this particular port. Okay. Till time communication won't be happen. Clear? Let's do a small lab. After that, switch, switch. And take one more switch because I do not have a Attacker PC, so I can take other switch and I will put this priority as a lower one as compared to these switches, right? Okay, done. Now let's convert the topology. Let me check the who is root. So who you will check? Enable. So is spanning tree, right? So all the port is designated port. you can say this is root, or else it's showing also this is root, or else third option is you can check the MAC address, bridge MAC address and root bridge MAC address. You will see both the same. It means it is DP port. I mean root switch. And you can say by default priority is 32,768 plus extended ID. Extended ID 1. That's what is showing 32,769. Okay, cool. So let's do a small lab, a small practice. And this port I will keep this one FA0/1 I will put as a shutdown as of now. Enable config interface FA0/1 shutdown. As of now, I will put as a shutdown in order to prove that like we are doing. And here will host name, just change host name, switch number 4, or you can say attacker. Attacker. Okay, attacker PC. So spanning tree VLAN 124094 priority. How you are going to change the priority? Priority I will put as a 0. Okay, done. Do right nothing else you need to do. It will be will be shut down until unless I will turn it on. Okay. Now this priority is 3768 and this is also root. So this is also something. So spanning tree. So spanning tree. Root the DP port. So as we learn, we need to enable the root guard on the DP port only. So here we have so spanning tree. Okay, no DP port. No need to do anything here. So let's understand the topology again. After that, I will do the lab. Okay. So what will happen actually? Here we will run a command spanning tree, guard root, GARD, guard root. Okay. I will run this command. Okay. In the all the DP port here, and this is DP, right? Here. And here no need to do anything because as we learned, only DP port need to enable the root guard. As soon as this is I have made as a priority as a 0, right? I made it. Let me check, cross check again. So it's priority is 0, right? For the all the VLAN. As soon as traffic will come here, as soon as traffic will come here, and protection we have enabled, this is forwarded here, this forward, this will blocking, so it will store, it will not forward, it will forward here. It's saying like it will start claiming like I'm a root. I mean, I can forward this one because whatever you are DP, right? You are sending a superior BPDU, but I receive another superior BPDU from this port. It will start sending, so it will ask like become a root port, and I will become a DP port because as you learned a multiple time how Hispanic T conversion is happening. You learn in STP, you learn in RSTP, and everywhere. So you can understand like what will happen in network once it will receive the superior BPDU. Superior BPDU is nothing but you learn, right? Lowest root bridge ID, then lowest caste, then lowest designated bridge ID, then again lowest designated port ID, then lowest receiving port. So all this is the superior BPDU, identification condition, you can say. So as soon as we receive, it will put that port into inconsistent state. Inconsistency. I mean BLK port, for example. After that, this will isolate from the network, and you cannot communicate whatever system is connected here and here. Okay. Let's connect the system as well. Uh, where it is. Okay. Let's connect to PC. PC here. PC here. Connect PC. PC here as well. Okay. Great. So assign the IP address as we discussed 1.1.1. Okay. Done. Then assign the config here as well. Now let me check it's reachable. It's pinging 1.1.1.2. Time out. and restart reachable, right? On the two, right? Okay, let me
Yes,
put
it's changing.
continuous ping. Okay, it's working, right? Tuple, I mean, spanning tree is working fine. Now, only thing, what will happen? Let me enable the root guard. Let me see it's supporting or not. It's very thing, big thing is there. Like some of the thing is not supporting by, this virtualization actually. Host name root. You can say root. So interface description do so is spanning tree. Okay, all DP port. So use the command as a range, interface range fh0/1 to 2, and spanning tree. That is command. Spanning tree. In question mark here, you will understand what are the things it's supporting. Okay, guard is there.
Relax.
Guard. Then we have only one command, that is root. Okay, put root. See, it's enable. How you will check it's enable or not? So spanning tree summary. This is the command. See, root base extended guard. Guard default is disable. Looking guard where it is. Okay, it will see only the which we have run in global configuration mode, I guess. But I can see config. No need to enable. Leave that. I will put into interface level only. I have enabled, right? Spanning tree root guard. Guard root. Here also we have one port. So spanning tree. So we have a DP port. Which one? This one and this one. It's user connected port. So you can also enable here interface fh0/2 to 3. So user connected port also is a DP port, right? Oh, sorry. Interface range fh0/2 to 3. Spanning tree guard root. Then now we have this port. One more port is there. So spanning tree DP port one fh/4 interface fh/4 spanning tree guard root. Okay, to write onion. All set. I have enabled the command. Here I have enabled. Here I have enabled. This port is enabled. This port is enabled. This port is enabled. Okay. Now I'm going to turn it on, and you will see what will happen. So let's on the simulation might be we can capture some of the packet. Spanning tree we have HTTP we have. Okay, only HTTP required. Let me turn on this port. Interface fh0/1 shutdown. Oh, sorry, no shutdown. Done. It starts sending the traffic. Let me generate the packet. Okay, it's fine. It's sent to here. Okay, this is sending a packet with superior BPDU. Let me see what is the inbound is coming up. Cost 0, right? And priority, what priority? Okay, where is the priority? I cannot see priority. Anyway, keep that one. Receive the packet. It's accept. It will send to them. As soon as send them, what they are doing, something you can next level. See, this port has a root guard enable has received the superior BPDU. This port move into root inconsistent state. Root inconsistent state. I can show you one more way, one more place how it will show it actually. But let me see. It's dropped, right? It's proved. Now, okay. Communication, it will stop working. See, let me put into real estate. After that, we will see. As I said, it will eliminate, I mean, isolate from the network. So right now it's isolated, right? This switch and this switch will be in protection. I mean, production. This switch will go out of network now, and attacker also will go out of network because we will not send even not only the DP, I mean STP traffic, but none of the traffic will be initiated, cannot communicate with this device. Okay, because we have isolated this. You can reach out to here till here, not on the till root. You cannot reach. Okay, so you can see as well here communication. Why is happening? Should not happen. Okay, let me see. It should be okay. Now I able to see. So it's see packet start dropping, right? Generally it should drop. In real world, you will see immediate packet will be start dropping because we cannot we cannot trust our, even though it's our network, but we will not trust on this device until unless, because one more thing is time, right? We isolate from the network, right? Until unless this device, this attacker will not remove from this device, till time this device will not be in the network. I mean, it will be in isolation state until unless this device will be not removed. How you will identify? We have kind of some endpoint security team and security team, you can say, in the network, in the company. They will identify. We can even we can also identify who is sending what traffic. We can capture. We have multiple tool. We have multiple way. We can capture which device is traffic generating the this one, because as we know, system cannot be initiate traffic for the STP one, because it is the protocol for the switches only, right? And system is generating any packet like that, so it's some suspicious users. It is. So what we will do? We will remove. We will shut down this port. And if other port is connected, other user is connected, for example, other switches, other devices is connected, server, computers, I will allow this traffic. This one will be dropped permanently. Until unless we will review, identify, we will punish them. Okay. Anyway, let's let's shut down the port again. Shut. See, immediate came into picture, right? I have not done anything. Immediate it came into picture and it start sending the traffic again. See, cool. Let me stop the recording. I will allow you guys to ask the question.